Hello, welcome back to BLENDERSUSHI live noding. In this episode, I'm gonna talk about this setup that I made using Sverchok. You can see there's an image right here, which is looks like a random array of colors, and you can see there's like a point cloud of something that looks like a teapot. Yeah, what is this? If you saw my recent Twitter, I posted few image of 3D mesh and looks like something that looks like random pixels color. That's actually the representation of the mesh as a 2D flat image. If you don't believe me, I'll show you. This is basically, so there's basically like a grid somewhere. Let me, oh, it's currently a point. Well, basically I have a grid and then I apply a displacement into that grid, and the grid itself will be displaced, right? And it's being displaced by all these pixels. Every single pixel will represent like RGB, but it will also represent the XYZ, which I converted from the original mesh, and I brought it back to Sverchok and then kind of compare the original grid and then the one that's being displaced, and then we get the point cloud back. Okay, this is actually the grid is over here, so we can see at 0, 0, 0 is just a normal grid. At strength of 1 being displaced by this image, that points, which is RGB to XYZ in the directions, is being converted back into point positions, which then we get something like point cloud representation of the 3D image. How did I do this? Basically, I used the setup from my previous live noding. So here it's actually quite simple. I'm sourcing this guy, the mesh, any kind of mesh, just a single mesh, and then the vector out XYZ is converted into RGB. But before I do that, I normalizing the value, find the highest minimum and highest maximum of every values here from the XYZ point positions, and then I zip it all together as RGBA, and then I pipe it into this object ID setup. So we have this image, and I specify Utah teapot in this case, which is this teapot, and then output the pixel, and then the result is this image. This will work with any kind of a 3D model. So in a way, we like converting from one data type into the next data type, and it's all because everything is kind of like a numbers, just a list of numbers representing RGB, not including the alpha. It's just from XYZ point positions into RGB, which is this guy, which is just like a bunch of pixels. It's actually quite small because the way I check this is like I go to edit mode of this Utah teapot and look at the points. It's 1292, and then I went to spotlight and then square root of 1292. It's like around 30, 35, 36, just make it 36. So what I did is just create a new image, 36 by 36 pixel. That's enough pixel numbers to represent this Utah teapot, kind of, because it's just the point cloud. It doesn't have any informations like the the edges or polygon. That's why it's a kind of like a simpler version, like a point cloud. But if you have like if you scan a person, for example, like, and you end up with 150,000 point cloud, or 1 million or something, you can turn that into like just like an image, and then maybe you end up like with 1000 times 1000 pixel of image. That image represents your 3D point cloud, sort of. So it can be interesting, and then you might also want to store the RGB value, instead of just the position. You want to also store maybe the color of each point cloud. You can also do that as a maybe as a separate image, or the same image. Maybe make it into a separate image, so each point has its own RGB value that you can kind of keep as an image. That way you really kind of flatten the 3D object into an image. Now you might wonder, why would anyone want to do that? It's my answer is I don't know either, but I remember there's an example of in Houdini. Actually, Stephen Tucker actually made the tutorial. I think Houdini RGB. Maybe he has it. He has it somewhere. Basically, he transfer like an animations. Let's say you have like a point cloud animations, like a vertex animations being displayed, representing like some kind of fire, and then you want to bring that into a game engine. And game engine doesn't like vertex animation. Game engine likes the maybe like join animations, but you want that vertex animation, so you kind of transfer image texture. You transfer the animations of vertex into sequence of image, and then you bring it back into game engine. That way you have vertex animations. It's quite an interesting hack. But for us, if you let's say we make something, a cone or icosphere. Okay, let's try icosphere. I'm gonna subdivide this icosphere so we have more subdivision. Apply, and this guy, let's see how many vertices it has. 242. It's quite small. I'm gonna subdivide it once again. 1979. Okay, 1979. 1979 is a 44 by 4. Maybe make it 45. I'm gonna make an image 45 by 45. Okay, and call it ico. So now we're gonna make a new image. Call it ico, and then just source this guy, and this should be post modifier. Currently, did I made a mistake here? Let me check. Oh, yeah, actually 962. Okay, 962. 30. Just make it 31 by 31. Ico. Okay. I'll name it something else. Blah. Now, this color represents our subdivided icosphere, believe it or not. So if I save this, save a copy as ico image, save. This setup I will save real quick for you guys. This is gonna be XYZ to RGB JSON. Save. Now if I open image to mesh, so here if I use that icosphere image real quick, so not the torus knot, but the icosphere. So I grab the icosphere and then with the displacement I also make sure this is the icosphere. If I refresh, and then I should be getting the icosphere point cloud. You can't really see the connection between edges, but this is really representing the icosphere. If I use maybe like KD3 closest edges, maybe I can connect the points. Well, it won't be accurate anyway, but the point cloud, my point is you can kind of get that result more or less. Maybe not super accurate at the moment, but this is this pixels represents the icosphere. I can try once again, but then no, I guess that's pretty much for this live noding. So basically, a way we can turn 3D objects into 2D image, which is rather, even such a low res can keep all these informations of the vertices, and you get this point cloud. I think I should try with with the scan of my 3D scan. 3D model, or maybe more like high-res model, and then show you the result. Anyway, I'll give you this Node 3 to try, and yeah, just let me know if you have any question. So anyway, I'll see you in the next live noding video. Thank you again for